46. An object falls freely from rest under the influence of gravity. If air resistance is negligible, the ratio of the distances traveled during each 1-second time interval by the object during the first, second, and third seconds of its fall is... Well, the first exercise here is to actually understand what they mean by the situation asked. What they're telling you is that there is this object that is falling in free fall due to gravity, and so it has certain characteristics that allow it to go faster and faster as it falls. That's of course due to the fact that the velocity is increasing continuously, like so. Now, we want to discuss what is happening with the distance traveled during these consecutive 1-second intervals. In other words, what they are asking about is what is the relationship between these distances that I just marked. Now, always remember that the word ratio refers to a division or quotient between distances. So you might want to consider the following idea. The displacement that an object has over a given time interval is given by 1/2 acceleration time squared. We don't include the linear v-initial time because the initial velocity is 0. Now, for time intervals equal to 1, 2, and 3, the values that we have are 1/2 a times 1 squared, 1/2 a times 2 squared, 1/2 a times 3 squared. And this is 1/2 a, this is 4 times 1/2 a, and this is 9 times 1/2 a. Since ratios are always marked as quotients or divisions, when you divide the first one into the second one, 1/2 a cancels and you get a ratio of 1 to 4. Same deal when you divide the second one into the third one, 1/2 a cancels again and you get a ratio of 4 to 9. Combining these three things, what this is actually saying is that the total distance from the beginning to each of these is related as 1, 4, 9. Now here we have to be careful because that's not the ratio that they're asking about. What they're asking about is the ratio of the distances traveled during each 1-second time interval. So you decide to subtract. If I have a span of 1 meter over here, this one is not going to be 4 meters. This is 4 meters from the beginning, so it's 3 meters for 1 second. And for the last second, that is 5 meters. So actually, the distances for consecutive seconds are related as 1, 3, 5, the odd numbers. And so your answer should be option D.